Hello, in this video, we're going to go over the check your understanding from 6.1b, continuous random variables. So the heights of young women can be modeled by a normal distribution with a mean of 64 inches and a standard deviation of 2.7 inches. Suppose we choose a young woman at random and let the random variable y, notice it's capital Y, equal her height in inches. What type of variable is y, discrete or continuous? So you want to ask yourself, is there space in between each outcome? We're going to make this continuous. Any height is possible. They could be 65.23814 inches. So there's no gaps in between. So this is continuous, a continuous random variable. Interpret the standard deviation, this 2.7. So the heights typically vary by 2.7, not 27, inches from the mean height of 64 inches. So now it says find the probability that your random variable y, so the height in inches, is less than or equal to 63. So they said the heights were normally distributed. So this probability distribution is represented by a normal curve. So make sure you sketch that. You label it with the parameters that it's normal with a mean of 64. And you could put mu sub y here. That would look great. Mu sub y equals 64. Sigma sub y equals 2.7. So here's 63. If your mean is 64 and you have a standard deviation of 2.7, 63 is somewhere between a z-score of -1 and 0. And you can convert that to a z-score, subtract the mean, divide by the standard deviation. That's a z-score of -0.37. You can look up -0.37 on the table A, the Z table, and see what's the area to the left of that. Or you can use your calculator, making sure you label all the parameters. You can go from lower bound -infinity to, this should say 63. We will just change that. 263 with a mean sub y of 64, standard deviation, and we get an area. Okay, so our area looks pretty similar to that z-score. The z-score is -0.37, and then the area to the left of that is 0.3557, or 35.6% approximately. So our interpretation here is there's a probability of 0.3557 that a randomly selected female is less than or equal to 63 inches. So you could give that as a proportion or a percent, either's fine. To get full credit on a question like this, make sure you draw the sketch of the probability distribution, this normal curve with the parameters labeled. Find the z-score and write that you're using table A, or write what you're inputting into the calculator with all the parameters labeled, and then interpret your probability in context. So then it says find the probability that your random variable, this should say y, I want to change the name of it, y is between 68 and 70, and then interpret it. So same sketch. So if you're going to find in between with the table, you turn both into z-scores, both 68 and 70. So this is a 70. Let me just make sure that's correct. So 6 divided by 2.7, yeah, that's 2.22 as a z-score. 2 over 2 standard deviations above the mean. 68 is only 1.48 standard deviations above the mean. Find the area to the left of it, and you'll do the area to the left of 70 minus the area to the left of 68, and that will give you the area in between. So that's this 0.562. I guess that should be 0.0562. Or do normal CDF from 68 to 70 with this mean and the standard deviation. Make sure you label all the parameters and you get that area. So for our interpretation, there is a 0.0562 probability that a randomly selected female is between 68 to 70 inches. Right, make sure you're showing all the proper work and you're remembering everything from earlier in the year that was necessary to do these normal calculation problems.